Section 5.7, using congruent triangles. So what we're looking at here is our definition of CPCTC, which is corresponding parts of congruent triangles are congruent. So this is a theorem that we can use. And as I talked about at the end of 5.6, this lets us go a step beyond proving triangles congruent. So we're going to look at proofs in this entire thing. We have 5 of them. Every proof we look at, we're going to be proving triangle is congruent and then adding a step where I'm saying my corresponding parts are congruent because the triangles are congruent. So our first proof, let's see, do it this way. All right. We're given that VS is congruent to UT and that ST is congruent to VU, okay, both of which are marked on my picture. And I want to prove that angle S is congruent to angle U. So the first thing I'm going to do is prove the triangle is congruent. We have 5 ways to do that. Right? We have side, 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 angle, side, hypotenuse, leg, angle, side, angle, and angle, angle, side. So we're looking at doing one of those. Okay. One of the things you can use to narrow it down is what you already have. So right now we have 2 sides. That means I'm not using either of the 2 angle ones. In a weird case, it could happen, but in general, that means that I'm not doing that. So I'm looking for what else I can mark here. We have the side they share, VT. So I'm going to do VT congruent to VT by reflexive. That then gives me that my 2 triangles are congruent by side, side, side. And then my last step is what I'm trying to prove. And if we're going beyond proving triangles congruent, my final step is always going to be CPCTC. All right, so again, that's saying I've proven the triangle's congruent. So now I know that corresponding parts are congruent. So S and U correspond and therefore have to be congruent. A lot easier to say CPCTC, okay, but that's what that statement is saying. Then our second proof. Right. So they give us that NM is congruent to PQ. They also give us that angle MNL, which is the angle over here at N, the angle MPQ, which is the angle over here at P, are congruent. Okay. And I want to show that LM, okay, this part, is congruent to LQ, which is that part. Okay. So we're trying to prove our triangle is congruent. Here we have a side and an angle. Right? And I don't have anything else that tells me anything about sides. Again, sides are the harder things to mark. I either need words given to me or them to share a side. But here at L, I do have vertical angles. So I'm going to say that NLM, clear up, or are you just going to be blurry if I zoom in? There you go. All right. NLM is congruent to PLQ, and that is vertical angles. So now I have this marked. So now I can say that my triangles are congruent by angle, angle, side. And then we're doing our last step. LM is congruent to LQ by CPCTC. I will point out that LM and LQ are not full sides of those triangles. So if we were being picky, we would want to get into the fact that this side and this side are congruent and then break it into parts. We've looked at some of those in the past, but that's harder than what we want to deal with for what we're doing here. So we're going to say that those two count as parts, even though they're not full sides. All right, so we're fudging it a little bit there, but it gets across what we want to get across there. Flipping the page over. Right. Where are we at here? Find our picture. All right, so example 3, we're given that AD is congruent to DC and AB is congruent to BC. I want to prove that angle A and angle C are congruent. And then I start with my given. So I have my sides marked. Then I have BD that connects, that is in both triangles. So I do BD congruent to BD by reflexive. And I can't see my reasons here. So then I prove my triangles congruent by side, side, side. And then angle A is congruent to angle C by CPCTC. Then going to example 4. So here, right, this one's a little bit more steps. We're given that GK bisects FGH and FKH. And I'm trying to prove that FK is congruent to HK. Right? It's already marked because I've used this before, right? But I don't, by this given statement, I don't actually have anything marked yet. So I start with my given. GK bisects these two angles. So FGH is this angle here. FKH is the angle on the other side. So whenever I have a keyword, I want to start. I have to zoom out a little bit there to see. Oops, wrong direction. Right. I want to start, but what that keyword means. So bisects means cut in half, right? So I have the definition of an angle bisector because an angle is being bisected. And I have two pairs of angles that are equal, one for each angle that is bisected. So FKG and HKG are congruent. They're the angles over at K by definition of an angle bisector. And FGK and HGK are congruent by definition of an angle bisector. Right, so that gives me two markings. Then I need my third. While they share this side here, they share side GK. So GK is congruent to GK by reflexive. Now I have my three markings. I have angle, side, angle. So I prove my triangle is congruent. And then I can say that FK is congruent to HK. Right? FK and HK by CPCTC. Because they're corresponding parts of congruent triangles. Right. And then 5, our last one here. Right. They give me that angle 1 is congruent to angle 2 and AE is congruent to DE. And we want to prove that DC is congruent to AC. Again, this is a little weird. They give me 1 and 2. All right, angle 1 is out here. Angle 2 is down here. They are outside my triangle. So I need to somehow relate those to stuff in my triangle because they don't actually count as markings when they're that way. Right? Because again, they're not in my triangle. So they can't prove the triangle congruent being outside the triangle. So I have my given information. Angle 1 is congruent to angle 2. Angle AB is congruent to DE. I know I want to use angle 1 and 2, but the easiest thing for me to see is vertical angles. So even though I know I want to use angle 1 and 2, I did this first. Angle ACB is congruent to angle DCE, okay, because they're vertical angles. So now I have an angle and a side. So probably I'm going, and I have this other angle here. So I'm probably going angle, angle, side, or angle, side, angle. It's just a matter of the order. So 3, and we've gone over this, but we haven't used it in a while. 2 and 1 are congruent. 4 and 3, the two angles in the inside, they make a linear pair with 1 and 2. So they have to be equal. All right? That's our congruent supplements theorem. It said if they're supplementary to the same or congruent angles, then they're congruent. Again, this is something where we could add in a couple lines to be clearer here. We're making it a little less difficult and just jumping right in. All right, so I say 3 is congruent to 4. So now my triangles are congruent by angle, angle, side. And my parts are congruent by CPCTC. That is the end of section 5.7.